Next is the object-oriented data model, wherein both data and its relationships are contained in a single structure known as an object. Much like the object-oriented programming that you might have already tackled in another course, the object-oriented data model represents our data. Next, we have the object-oriented data model, wherein both data and its relationships are contained in a single structure known as an object. In this model, real-world problems are represented as objects with different attributes. Now, all those objects have multiple relationships in between them. For the object-oriented data model, we have the following. We have the class, which is referred to as the collection of similar objects with shared structure and behavior organized in a class hierarchy. The class hierarchy, which resembles an upside-down tree in which each class has only one parent. Inheritance, wherein an object inherits methods and attributes of the classes above it. And the Unified Modeling Language, or UML, which describes the set of diagrams and symbols to graphically model a system. Here we have a comparison of the object-oriented, the UML, and the entity relationship models. For the advantages of the object-oriented model, we have the following. First, the semantic content is added. Second, visual representation includes the semantic content as well. And lastly, the inheritance promotes data integrity. For the disadvantages, we have seen slow development of standards for the object-oriented model, which has caused the vendors to supply their own enhancements. We also have complex navigational system since we are representing the real-world objects as an object. We also have learning curve that is very steep because not everyone can grasp the concept easily. And we have high system overhead which slows down the transactions. And we also have the extended relational data model, or ERDM, which is an extension of the object-oriented data model. So it supports the object-oriented features, but in addition, we also have the extensible data types based on classes and inheritance. For the database management system, we have the object or relational database management system, which is based on an ERDM. And we also have the XML, or extensible markup language, which manages the unstructured data for efficient and effective exchange of structured, semi-structured, and unstructured data. Now, the way we are generating data and collecting data over the past few years has dramatically changed. Therefore, we need to find new and better ways to manage the large amounts of web and sensor-generated data that we have been accumulating over the years. And the goal is to provide high performance at a reasonable cost. Now, what characterizes big data? We take a look at the 3 V's, which are volume, velocity, and variety. Volume refers to the amount of data being stored. Velocity refers to the speed by which data grows and need to process data quickly in order to generate information and insight at a glance. And lastly, variety, which is referring to the data being collected comes in multiple different data formats. The following video differentiates the NoSQL and SQL databases. I have posted the link here in the slide and I will leave it to you to visit the link and watch the video. The following are the challenges of big data. First, the volume doesn't allow usage of conventional structures that we currently have in a SQL environment. It's also expensive because, as we all know, we are gathering a lot of data, huge amounts of data, which means huge amount of storage. And the OLAP tools prove inconsistent dealing with unstructured data. Now, there are new technologies that are introduced over the years to handle the big data. We have what we call Hadoop, which is a Java-based open-source, high-speed, fault-tolerant distributed storage and computational framework. Also have the Hadoop Distributed File System, or HDFS, which is highly distributed, fault-tolerant file storage system designed to manage the large amounts of data. Also have MapReduce, which opens source application programming interface that provides fast data analytics, and NoSQL. For the NoSQL databases, these are not based on the relational model. They support distributed database architectures and provide high scalability, high availability, and fault tolerance. They also support large amounts of sparse data that is geared toward performance rather than transaction consistency. They also provide a broad umbrella for data storage and manipulation. The following are the advantages of NoSQL database. High scalability, availability, and fault tolerance are provided. It uses low-cost commodity hardware, supports big data, and the key value model improves storage efficiency. For the disadvantages, complex programming is required. There is no relationship support. There is no transaction integrity support. And in terms of data consistency, it provides an eventually consistent model. The following figure provides a brief overview of the evolution of the data models. We can see each of the data models with the year to which they were introduced and some of the concepts that we have discussed along the way. We can see that hierarchical data model was introduced in 1960, network data model in 1969, relational data model in 1970, entity relationship data model in 1976, semantic model in 1978, which gave rise to the object-oriented model in 1985, and the extended relational model in 1990. And lastly, the introduction of NoSQL databases in 2009 to handle the big data problem. Next, let us discuss the degrees of data abstraction. We start with the external model, which is the view of our end user, and then the designer's view for the conceptual model, the view of our DBMS or database management system, which is the internal model, and finally the physical model. On the table on the right, you can see that the more hardware and software independent we become, the higher our degree of abstraction is. First is the external model or the model from the view of our end users. An example of which are the following. If we have student registration or class scheduling, this is how the external model might look like in the eyes of our students or our clients or end users. Again, the external model is the end user's view of the data environment, and we are using entity relationship diagrams to represent the external views. We also have external schema, which is a specific representation of an external view. And as you have seen in the previous slide, for our example, the external model is usually limited to the processes that are experienced by the end user themselves. Next is the conceptual model, or the view of our database designer or the entire organization. Next is the conceptual model, which represents a global view of the entire database by the entire organization. It has conceptual schema, which is the basis for the identification and high-level description of the main data objects. It also has logical design, which is the task of creating a conceptual data model. Now, the advantages of having conceptual model are the following. You have a macro-level view of data environment, so all of the relationships, all of the entities can be seen in the diagram. And the conceptual model is also software and hardware independent. So you have a high level of abstraction. Next is the internal model, or the model from the view of our database management system or DBMS. As you can see from the conceptual model, we can translate them into create tables, scripts that we are going to discuss in more detail as we go along this entire course. The internal model represents the database as seen by the database management system, mapping conceptual model to the DBMS. In the internal model, we have an internal schema, which is the specific representation of an internal model using the database construct supported by the chosen database. We have logical independence, which is changing internal model without affecting the conceptual model, and it is also hardware independent, wherein it is unaffected by the type of computer in which the software is installed. And lastly, we have the physical model, which operates at the lowest level of abstraction. It describes the way data are saved on storage media such as magnetic, solid state, or optical media. It requires a definition of physical storage and data access methods, so you can see that it is software and hardware dependent. Its relational model are aimed at logical level. It makes it not require physical level details. It also has physical independence, which changes in physical model do not affect the internal model. And in this table, we can see a summary of the different models, their degree of abstraction, their focus, and which are they independent of. Okay, in this lecture, we are able to discuss the following. We are able to discuss the differences between the following models, their advantages and disadvantages. We have hierarchical model, network model, relational model, entity relationship models, author models, and we ended our discussion with the degrees of data abstraction.